Round of applause for Gonzalo.
Good morning. Can you hear me? Too loud? Too loud? That works? Good morning. So, the aim of this talk is to share with you how we build an exception tracker in and for Elixir application. So, hopefully, you can easily try to solve that in your own applications or better assess what exception tracker package to use as a dependency. So I've been in Elixir for 5 years so far, and I currently work at a company named Mimicwait, sponsoring this event. We're a team of software engineers building software for other companies, mostly in Elixir and JavaScript. Today, breakdown, first talk about the motivation, why build an exception tracker. Talk about a bit the build process and the end result and the publish of a package. First of all, quick clarification. By exception, I don't mean error handling, like error tuples or like expected errors from users and stuff. So I mean actual unexpected exceptions breaking the normal flow of a program, like in that case an arithmetic exception or manually erasing an error, an exception. So in an Elixir application, typically having a process tree, there's an exception in a process, we let it crash, but we still want to know, get information about what happens so that we can fix that, prevent it from happening. That is to say, exception tracking or monitoring. So, why? 2 years ago, at the beginning of 2023, Mimicwait, we released a small subscription-based web product built with Elixir and Phoenix. We had it initially configured to report any unexpected exception automatically to our rollbar account using a package called rollbacks. And a few months later, we had a bug in our application that was initially caused by the occurrence of a runtime exception for which we hadn't been notified in our rollbar account. So looking back in the GitHub repository of this package, it hadn't been maintained for a very long time, for at least a few years. There were some users claiming in issues and sample requests that some exceptions were not being tracked if using the latest version of Elixir. So we recycle, we forked the repository, recycle a few of the proposed changes on some of those pull requests from some users, and kind of work around that in that way for our, at the moment. A bit more than a half a year later, as we were keeping our application up to date with the latest version of Elixir at the moment, we realized that the latest version, Elixir had made further changes that were affecting rollbacks listening strategy to exceptions, and the project still appeared to be inactive. So we can only thank the authors and maintainers of rollbacks or any other open source projects, probably pro bono work, but at the time we kind of decided to, okay, let's solve this ourselves, because there's not a lot of movement there. So we decided to try, see how far we can get building something for ourselves. So first, only focus on the listening of the of exceptions within our own application. Try to solve that first and then see. So we ask ourselves, how do we listen in our Elixir application? We learned that reasonable options were number one, using plugs error handler to listen to exceptions inward requests using the model in a router and implementing this callback handle errors, receiving the plug connection and the exception. But important to note that this will only listen to exceptions occurring in web request processes. Number two, listen to telemetry events of that package sometimes emit when handling exceptions and notifying about exceptions occurring, among other telemetry events. Or hooking into the Erlang and Elixir logging system with handlers and handling log message that may include exceptions within those messages. So to us, it seems that this was the most comprehensive potential solution to be able to listen to all the exceptions that can occur in a Elixir running system. Looking back at rollbacks, now that we learn more about listening strategies, we realized that rollbacks was using a mix of plugs error handler for web request exceptions and error logger module for a handler, an error logger handler for other processes exceptions. And there have been major improvements in the logging system in both Erlang and Elixir in the last few years. In particular, error logger from in Erlang LTP had been deprecated and was replaced since Erlang version 21 with a new module called logger. Then the uppercase logger, the Elixir logger, which was back in the day a gen event with logger backends and integrated to the Erlang error logger, had been transitioning to become a fully integrated wrapper of the new Erlang logger. So in summary, maybe helpful to look at a timeline. Up to 2018, Elixir logger integrated with the error logger. Then a transition period within Elixir 1.7 and 1.15, starting to integrate to the new logger on Erlang, and error logger becoming deprecated. And from 1.15, or Elixir 1.15 onwards, fully considering deprecated error logger and just integrated to the Erlang logger. So now we better understood what this issue on rollbacks actually meant. Users asking to register and listen to the logger events and not the error logger. So we were fully convinced that this was the way to go to use the new logger to listen to exceptions. So looking in the metadata in the documentation, in the metadata section, down there's a mention of something called the crash reason, that quote in the documentation, whenever a message is logged, additional information can be given via metadata. And the crash reason contains a two-element tuple with the exception reason and a stack trace. Also, in the documentation, stating that the default formatter, here talking about the default Elixir formatter, logger formatter, ignores this metadata by default, but it can be useful to certain handlers, such as the one that report to third-party services. So, seemed perfect for us. A logger handler can be any module that defines this function. You subscribe this handler and to the logger, and you just start receiving what is called log events. So the plan for us was first disable rollbacks listening or within our application and start playing with a lower handler matching on the crash reason. First, very dumb implementation, just print what we received and hook into the logger with this lower handler. So if we raise an exception within an unlinked asynchronous task, we receive a log event with a crash reason in the metadata and the stack trace as a list as the second element in the tuple, in this case abbreviated for space reasons in this slide. What about if we manually log an error to the logger? In that case, we also receive an event, but without the crash reason, so that makes sense. So we improved the implementation to match on crash reason to get all the events that included an exception, and at the moment just report this with a function that continue using rollbacks report functions. We didn't want to mess with that at the time. So do we still need to use plug error handler if we have a logger handler? As far as we could tell, web request exceptions would still land in the logger as logger messages. So either when using Cowboy or Bandit. So technically we didn't, and we didn't add that. Push to production and everyone happy. But after a while, we realized that Oban job exceptions were not being reported. And that was because Oban's job executor rescues exceptions within jobs and doesn't re-raise the exception. But it emits a telemetry event with the exception information instead. So let's add a telemetry event for this special case. We handle the exception event, in this case an Oban job exception, and we call the same report functions within that handle exception event function. So this is what we ended up more or less. Fix to production, happy again. After a few weeks with this in production and a few more improvements, not worth mentioning, we were happy with the solution so far. So are we done? Are we tracking everything? We were not. Also quoting the documentation, Elixir has 3 error mechanisms: errors, throws, and exits. So this is talking about what in Elixir is called the exception kind. In Erlang, it's more like it's called the exception class, I think. So errors are what we normally see as Elixir exception structs, but it can also happen that there's throws and abnormal exits. Maybe not that common in Elixir programs, although it can happen. It can be done, but maybe a bit more common in Erlang programs, which of course we do use or we do depend on. So we still need to track this. So back to the crash reason. In reality, the crash reason can be a 2-element tuple in which the first element, I lied before, it's not always not necessarily always an exception struct. So it can have different shapes. It can be an Elixir exception most commonly, but it can also contain the thrown value with this special tuple with a no catch atom. For example, in the case of a thrown string, or in other cases, just the exit reason as most commonly as an atom. Quick verification: if we throw a string in an unlinked task, we do receive the log event with the crash reason on the metadata. So we improve our loader handler to have 3 different clauses. One when this is the first element in the tuple is an exception, when it is a throw, or where it's an extra reason. Yeah, fixed to production. So after we were pretty happy with the listening logic, we started thinking what we do with reporting. Should we re-implement the report to rollbar and package this in a new package that's a rollbar notifier? Maybe we were not sure. We were just solving exception listening, and on top of that, we realized that this very same issue that rollbacks had was happening to other Elixir packages, like the backsnag Elixir package. So users also there asking, reporting the same issue. Again, we can only thank the author and maintainers of backsnag, but this package was also appeared to be inactive, so that was enough reason for us that so it felt that this listening logic that we were working on would be kind of wasted if only packaged with notifications to only one third party because of that. So we started thinking about publishing this open source and in a decoupled way. So let's just package the exception listener in a new self-contained package and let reporters be a configuration option. So after a few months, we extracted the listening logic from our application into a new package, and we call it Tower. We say it's a vendor agnostic or just an agnostic exception tracker because of the decoupling. In summary, it attaches the handlers that we discussed when the application starts. It defines a reporter behavior that only defines one callback, handling an event, and on any exception detected, it builds a well-defined struct called a tower event and passes this along to the configure reporters. A quick peek into the tower event. And then we worked on published separate package called Tower Rollbar, which just depends on Tower. It doesn't know anything about exception listening. It just implements this behavior, which is handling the event. It turns on that Tower event into whatever JSON is needed by the Rollbar API, and it sends a request to the API. After a few months, we continue implementing reporters, Tower's backsnag to fix the problem that these other users that we saw were reporting on backsnag. Tower email, Tower Slack, and a few more. So in summary, what we ended up having is what is common on a service, like on a third-party service library, that the capturing or listening, formatting and reporting of the exception is self-contained within one package. What we ended up was having this decouple of responsibilities and having the listening and the building of this well-defined structure on one package, and then reporters be separate. So potentially the possibility of having more than one at the same time. Fast forward to today. After more improvements and maturing it over more than 20 versions released, We're at 0.8. Not too far from a stable v1 probably. There's maybe a few more things that we may want to work on to make it more mature. But right now, what you can do is you can depend on the reporter package and make the configuration of in the reporters list, and put probably a few other configurations like an API key for third party or a few more like that. But it will just by doing that, it will start automatically listening to exceptions and reporting to this third party in this case. That's a peek into the available reporters. Or you can depend directly on Tower and implement your own custom reporter, implementing the reporter behavior. There's also this thing we have built in on Tower, which is called the ephemeral reporter. This is built in, and it will just retain the last 50 exceptions that were listened. So it can be useful for development or testing. Maybe also in production, if you want to peek into your console and just introspect that, what were the last 50 events. Optional features, not enabled by default, but it can be enabled to also report logger messages, like logger.error or logger warning or info messages. Ignore some exceptions, of course, and ask for some metadata keys to also be reported. Like, for example, one common use of that is the request ID on a finished application. Wrapping up. So we learned a bit about all these modules and how we can use this to listen to exceptions. Special shout out to the OTP and the Elixir team for their awesome work on improving the login experience within these last years and making our work very easy. So closing out, I hope I was able to shed some light on the inner workings of exception tracking in Elixir. Maybe help you accomplish this in your project if you want to code it yourself, or maybe better assess and decide which package to use, or whether you are tracking exceptions with the way you want or the way you expect to with the package that you're using right now. So thank you.